What happens when you fall into a black hole? No, I don't mean theoretically. I mean you, a living astronaut, crossing the threshold of one of the most mysterious and deadly objects in the universe. What would you see? What would you feel? And would there be anything left of you to tell the story? Black holes are regions of space-time where gravity is so strong, nothing, not even light, can escape. At first, approaching one might not feel that strange. If it's a supermassive black hole, like Sagittarius, a star at the center of our galaxy, you could cross the event horizon without even noticing. No sudden pull, no explosion, just silence. But from that moment on, you're trapped. There is no return. You've crossed a point where the rules of physics begin to bend, and reality itself begins to break. As you get closer to the black hole, time begins to slow, but only from an outside observer's point of view. To someone watching from afar, it would look like you're moving in slow motion, frozen at the edge. But from your perspective, inside your ship, time feels perfectly normal. It's only when you look outside that you realize the stars have started to blur, stretch, even vanish, because light itself is being pulled in. But before that, a brief history of black hole research. 1784. The first idea. British scientist John Michell proposed that there could be an object with gravity so strong that light could not escape it. He called it a dark star. 1915. Einstein's theory of relativity. Albert Einstein publishes The General Theory of Relativity, which predicts the possibility of black holes as solutions to the equations of gravity. 1916. Schwarzschild solution. Carl Schwarzschild finds the first exact solution to Einstein's equations for a spherically symmetric body. This becomes the theoretical model of a black hole. 1960s to 1970s. Recognition of black holes as real. Black holes transition from being a mathematical curiosity to real astrophysical objects. Scientists, including John Wheeler, introduced the term black hole. The hunt for X-ray sources associated with black holes begins. 1974, Hawking radiation. Stephen Hawking combines quantum mechanics and gravity, predicting that black holes emit heat, known as Hawking radiation, and can eventually evaporate. 2015, gravitational waves. The LIGO Observatory detects gravitational waves from the merger of two black holes for the first time. This provides direct evidence of their existence and interaction. 2019, the first image. The Event Horizon Telescope project releases the first ever image of a black hole shadow in the galaxy M87. For the first time, the world sees gravity in action. 2022, image of Sagittarius A. Scientists capture an image of the supermassive black hole at the center of the Milky Way, confirming that our own galaxy is anchored by a giant black hole. So, let's return to the three main theories. Theory 1, the singularity. According to Einstein's general relativity, all matter inside a black hole collapses into a singularity, a point of infinite density. It's where time and space stop behaving like we understand them. Your body would be stretched and compressed by gravitational forces in a process called spaghettification. Eventually, you'd be torn apart on a molecular level, and everything about you would vanish into a single point. But this creates a paradox. If all information is lost, it violates a fundamental rule of quantum mechanics. Theory 2. Information is never lost. Quantum theory says information must be preserved. So some physicists, including Stephen Hawking, suggested that black holes emit tiny amounts of radiation, now called Hawking radiation. Over trillions of years, this could cause black holes to evaporate, slowly releasing the information they consumed. Does that mean an astronaut's last thoughts, last images, last moments could be encoded in radiation? We don't know. But if true, black holes might not be one-way trips after all. 3. The wormhole. And then there's the most mind-bending idea of them all. What if a black hole is actually a gateway, a tunnel through space and time, known as a wormhole, connecting distant points in the universe? If you pass through it, you might not die at all. You might wake up somewhere else, in another galaxy, another universe, or another time. The equations allow it. Reality? That's still up for debate. In 2014, the movie Interstellar dared to imagine this journey. Its black hole, Gargantua, was based on real physics and consulted by Nobel Prize-winning physicist Kip Thorne. In the film, time near Gargantua passes hundreds of times slower than on Earth, a direct result of gravitational time dilation. When Cooper falls into the black hole, he doesn't die. Instead, he ends up in a fifth-dimensional space where he can see time as a physical dimension. He communicates with his daughter in the past using gravity. Is this possible? Scientifically, probably not in that form. But conceptually, it's based on real questions in modern physics about higher dimensions, information flow, and the nature of time. In 2019, scientists captured the first image of a black hole shadow in galaxy M87 using the Event Horizon Telescope. It proved that black holes are real and that their event horizons behave just as Einstein predicted. But what lies inside? We still don't know. No telescope can peer past the event horizon, no signal can escape, and no human has ever returned to tell the tale. But what if the center of a black hole isn't the end? What if it's the beginning of something else? A new universe? A reset? A mirror? Or is it the ultimate vault where the secrets of time, space, and reality itself are locked away forever? What would you see if you reached the heart of darkness? Like the video, subscribe for more explorations into the unknown, and let us know in the comments. Would you enter a black hole if you knew you'd never return?